All right, so let's talk amide structures, naming and drawing. Okay, so the carboxyl group is going to provide us with our parents. We are going to replace the oic acid with amide. Now, with our locants, there's no, for our primary amides, there is no N designation needed. We will see a change in this when we get to secondary and tertiary. So, we've seen this one before, this acid, right? We've named this before. This is methanoic acid. Now, as soon as that gets replaced with an NH2, right? So I have the same formula here, but instead of the OH, the hydroxyl, I now have an amine. So what I'm going to do for naming this is I'm going to drop the oic acid and I'm going to replace that with amide. So this becomes methanamide. All right, this is my amine, my methanamide. Okay. All right, so now we have moved on to naming our secondary amides. So we're going to designate our smaller alkyl groups with a nitrogen. Numbers are used for locants on the carbon chain, and the N is again used to identify groups that are going to be bonded to the nitrogen. Okay, so with our first one here, we are looking at, let's identify our two regions. So I have my carbon with my carbonyl, and then I also have, let's do blue, I have my amine, and then I do have a methyl group on that amine. Okay. So let's go ahead and start naming this. So the parent name is going to be based off of the carbonyl. So this is going to be, let me make sure I'm writing with the correct one. Let me do that in green. Methane is the parent, and I am going to, or methanoic acid is the parent. I'm dropping the oic acid and replacing that with amide. Okay, now I have that methyl group. That methyl group is bonded to the nitrogen, so that is going to be an N-methyl. So this is N-methyl methanamide. That's a mouthful. All right, let's move on to our second compound here. Let's go ahead and identify our carbon chain. So here is our parent carbon chain with the carbonyl. Now the carbonyl is always carbon number 1. Oops. Let's get this in the right pen. 1, 2, 3, and 4. Okay, so I do have a methyl group here on carbon number 3 on my parent chain. All right, let's identify my amine. I have my amine here, and I do also have a methyl group on that amine. All right, so my parent, I'm going to do the parent in purple. Let me say purple. All right, so my parent is going to be what would have been butanoic acid, 4 carbons. So I'm changing this to butanamide. Actually, I'm going to give myself a little bit more space here. Butan is my parent. Change the ending to IDE, so butanamide. Now, I have 2 methyl groups here. One is bonded to the nitrogen, one is bonded to my parent chain. So I need to identify each of those. So it's on carbon number 3. That's my locant value. It is also bonded, or have one also bonded to a nitrogen. So it's 3N methyl butanamide. All right, so let's go ahead and tackle our tertiary amides next. Again, we're going to be identifying our smaller alkyl groups with N. Numbers are used for the locants on the carbon, and the N is used for the identifying groups bonded to the nitrogen. All right, so let me first identify my carbonyl and my parent chain. So here we are. I have 2 carbons. That parent then is going to be an F. My amine, is right here. I'm changing the ending here to amide. So this is an ethanamide. Now I do have 2, we'll do these in green, 2 methyl groups bonded to the end. So that is going to give me an N. Did not give myself enough space. An N dimethyl. So NN dimethyl ethanamide. All right, let's discuss aromatics. So as we talked about before, our aromatic carboxylic acid is benzoic acid. If I replace that hydroxyl with an amine, that becomes an amide, and the name is benzamide. All right, for our common naming, our carbonyls will follow the common naming format, form, acete, propion, butyr, plus the word or term amide. All right, so if you remember from the previous slide, we talked about this as being methanamide. We are replacing that methan with form. So the common name for this would be formide. Formamide. Got it. All right, and for our second one, again, when we named this earlier, this was our N-methyl methanamide. This now becomes, using the common name format, N-methyl, because I still have to talk about where that substituent is bonded to the nitrogen, but I'm changing that methan to formamide. That's hard to say. All right, woohoo, it is your turn. So remember, when we get to a point like this, pause the video, make sure you can name this before I show you the name. All right, so our first molecule, here is my parent chain. I have 2 carbons. This is going to be an F. It's a primary. There are no substituents on the nitrogen, so it is simply an ethanamide. All right, this next one looks horrific. It really is not that bad. All right, so let's follow this general procedure. I'm going to look for my carboxylic acid derivative first. So here's my carbonyl. Here is my derivative. That I'm going to write in green. Make sure I use the correct pencil. This is a benzamide. All right, now this is a tertiary amide. So I have two groups here. I have we'll do this in blue, an ethyl group right here. And I guess we'll do this in red. I have a benzene ring right here. What do we call? So let me write these out. Okay, so this is an ethyl. So remember, when we are looking at a benzene ring as a substituent, it is called a phenyl. All right, I'm going to go back and erase this because I don't think I have enough space. So, yeah. Sorry about that. So benzamide, okay, that's our parent. It's in yellow. Now I have a phenyl and I have an ethyl. They are both bonded to the nitrogen. So this is going to be an N-ethyl and an N-phenyl benzamide.